Nuclear fusion, that is another energy idea that we have that we could use nuclear power for. And it involves, it's actually exactly the opposite of fission. Fission, you took a large nucleus and you split it. With fusion, what you do is you take a very small nucleus and you slam it together. You take a little hydrogen nucleus and another hydrogen nucleus and slam them together to make a helium nucleus. And this is actually what is happening on the sun right now. And every star, if you go out and look at the sun or any star, you're actually seeing the effects of fusion. And so it gives off a huge, huge amount of energy, more so than fission does. And it uses hydrogen. We have lots and lots and lots of hydrogen. And it makes helium. We're actually running out of helium right now. I don't know if you've been to a store to try to buy a helium balloon lately, but we're running out of helium. The helium stocks are going down, supplies are going down, and we need more. And so it would make something that at worst wouldn't hurt us, and at best we would want, using up stuff that we have lots of, makes crap loads of energy. And so why don't we do this? Well, the reason we don't do this is because this positive nucleus and this positive nucleus, we have to get them super, 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 super close in order to get fusion to work. They got to get like touching, but they're both positive, and like charges repel. They don't want to be together, and so you have to push them together really, really hard. And the way we do that is by getting them super, super hot and get them moving around really, really fast. And you got to get them so fast that they boom, slam together to the point they stick. And when they stick, that's when you get the huge amount of energy out. But the problem is, by the time you have spent enough energy to get them going fast enough to slam together, they give off lots of energy, but no more than what you put in. In fact, they give off less than what you put in to get them to fuse. And so it does make a ton of energy, but you use a ton of energy, and so you don't get any energy out of it right now. So right now, fusion is theoretical in terms of our application. We can make it happen, but it's not practical. And so the advantages, there's 1,000 advantages. The advantages are that it's clean, it's virtually renewable forever, as long as we have hydrogen. Renewable is not probably the right word because we can't actually make more hydrogen, but we got so much of it, it'd take forever to run out of it. And it's clean, renewable, tons of energy out of it. This would solve the energy problem. We would not be talking about energy problems if we could make fusion work. The disadvantage, like I said, is that unfortunately we can't get it to work. It doesn't make energy yet. Doesn't make energy yet. It does, but not more than we put into to make it happen. So those are the advantages, the pros and the cons of fusion.